Hi, this is Melanie Fainall here to talk about the application project for Module 1 using the simple thermometer. So I created my simple thermometer. I used just 12-ounce water bottles and painted them with black and white acrylic paint that I had at home. And then later on you'll see in pictures I did put white and yellow balloons over top of them. So first step to the engineering process is identifying the problem. And the question that I would pose to my students is, where is the best place to put a terrarium in our classroom? Or for the purpose of this experiment right now, where is the best place to put the terrarium in my house? And how I was going to tie it in is with our third grade science curriculum, we look at the water cycle and tools to measure weather. So that deals with thermometers, barometers, rain gauges. So I thought this would be a cool activity to kind of tie into our plants unit even as well. Below I have some standards for our third grade curriculum that relate back to the water cycle and the weather tools. All right. Once I had that question, I had to do some exploration. I had to research how to make a terrarium. I needed to look for what materials did I need, what are the different layers of a terrarium, so that we can make an effective terrarium that's going to have a plant grow. So then after I did my research, I came up with the design of putting the terrarium in a ball mason jar. At the bottom it would be a layer of rocks because that needs to act as a filtration system. Above that is activated charcoal. The purpose for that is to keep the water and the things inside the terrarium from molding. Then you have the soil, which all plants need, and then moss on top. The reason I wanted to do moss was because I thought it would give enough room in the mason jar so students could be able to see the water cycle happening. So as I went to go get the materials, I had to do some redesigning just because I was having a difficult time finding them. So I couldn't find activated charcoal, so instead I used grilling charcoal. And then I was having trouble finding moss, so I bought little succulents to put in instead. So then I started to create my terrarium. So I did a rock layer. Then I did my charcoal layer, and what I did was I took two hefty quart-sized bags, put some of the charcoal pieces in there and a hammer and just smashed it. If I were to do this again, I'd probably put it in another bag or two, just because once the charcoal breaks up, it pokes holes into your bags. So it is very messy. Just keep that in mind if you do that. Then I added the soil and the succulents. Now the problem was, as you can see from my left-hand pictures, the succulents took up almost the rest of the mason jar. So that wouldn't be good. Because students wouldn't be able to see the water cycle happening. So I didn't have any bigger mason jars to re-put them in. So what I did was I did some research and I found out how you could prune the succulents. So you just take off the bottom layers and you're just left with the top. So that's what I did on the right hand side. And once I had my terrariums, I was ready to go. So I put two terrariums in my house. One was in my dining room on my window ledge with two of the simple thermometers, and the other one went in my kitchen with two of the simple thermometers. So an hour later I went and checked on them, and I noticed that the jars started to have a little bit of a mist on the inside. So they were starting to, the water was starting to evaporate and condensate around the outside edge. But my simple thermometers weren't showing any difference from an hour before. Alright, then I went out, did some errands, came back at 4 o'clock. I definitely started to see more defined condensation on the inside of the jar. They looked more like smaller water droplets. But I also did not see any changes in my simple thermometers. Then about 4 hours later I came back and checked, and I definitely saw big water droplets. A lot of them were starting to pill down the side of the jars, but I still was not seeing any changes in the thermometers. So round one, pros definitely saw the water cycle happening. It also could pose some conversation with inquiry, because at one point I picked up the jar and the side closest to the window didn't have any condensation, where the side of the jar that was away from the window had more condensation. So that'd be a cool way to talk about that with students, and also even have them talk about explaining why are they seeing those droplets on the side, what's happening, so they can talk through the water cycle of the whole process of evaporation, condensation, what is going on in that jar. The bad part was there was no change in the simple thermometers, and that was a big part of the experiment. So solution that I decided on is the next day I would put a terrarium and the simple thermometers in a spot that got more sunlight. So next day I took one of my terrariums and my simple thermometers out to my back porch. I noticed the water cycle continuing, and as you can see from the first picture, the second, and the third, you can definitely see a change in the simple thermometers. The balloon is getting bigger. Now, the problem that I had with putting them outside was both of my simple thermometers like to travel off my porch. So definitely, if you put them outside, maybe, I have my bag of rocks over there. I'd put some rocks on the inside just so that it'd be more stable and have something to weigh it down so the wind wouldn't blow it away. So thinking too, if I'm going to use this with my students this school year, I would definitely get bigger jars. The reason for that would be, as you can see with the plants, being able to put the plants and the materials in a lot easier. And I would also like to add a rain gauge. I was thinking of using those little medicine cups that come with liquid medication and sticking that in there and putting it right next to the edge of the jar and seeing how much of the water gets in the grain gauge. And that would be a good way to do math and measurement along with volume. And that was part of my original idea, but when I saw how small the jars were and how little room I had, that was one thing that I had to change with my design. Also, I think it's important to put some terrariums near places that get a lot of sun and some that don't get direct sun, so at least they can see the water cycle happening, but then maybe have that conversation about why are some simple thermometers in some areas showing temperature change and why are some not. And that could be a good conversation piece with your students. So looking at the how this activity deals with the whole STEM continuum, I think it does a lot of things with science, such as developing and using models, because you're creating a model thermometer. If you add the rain gauge, that'd be one too. Plan and carry out investigation. They'd have to create their own terrarium, figure out where it's going to go and collect the data, and then analyze it, interpret the data. Why are we seeing condensation happening here? Why does one side have it and one side doesn't? Create explanations using that vocab that we learned. Engage in argument from evidence. So going back to why are some simple thermometers showing temperature change and why are others not? And then being able to communicate that information with other students or the teachers. This one definitely a lot of engineering, at least on my part, with creating it, defining the problem, creating that model, doing very similar things that are happening in the science section. Designing solutions. So if this isn't working well, why isn't your thermometer showing temperature change? What can we do to see if we can, if it can change, or maybe if it's not working? Technology, I think, build a simple thermometer is a type of technology, and temperature definitely plays a big part in our relationship to the environment, how we grow things. So I think that would play very well into that part. And with math, this area, using the appropriate tools strategically, so making sure you're using the correct science tools, or even if you use the measuring cup to go along with it. I think it'd be cool to even add in maybe students are graphing, they are maybe measuring how tall the plant goes, measuring how much condensation or precipitation is being collected in those cups. And that would also go with attending to precision. So you could do a whole bunch of different other math activities to go along with this. It just this is more of like the springboard for it. Okay. Alrighty. Well, thank you so much for listening to my presentation. I hope you have a great day.